So this is part 2 of multiplication and division. So if we had to multiply a fractions, for example, and whole numbers. So this is something of a review, just a very short review. So 1/5 or 1 over 5 times 4 is the same thing as 1 over 5 times 4 over 1. So if when we multiply the numerator and then we multiply the denominators. So this is 1 times 4 and this is 5 times 1. So we get the answer of 4 over 5. Again, it's the same thing. So 1 over 5 times a. So that's 1 times a. Then that's just an imaginary number 1 at the bottom. So that's 5 times 1. That's a over 5. Another example is 2a over b times 5a over 2b squared. So we multiply the numerator. That's 10. That's 2 times 5. That's 10. And then a times a is a squared. And that's there's an imaginary number 1 here. So 1 times 2 is 2. And b times b to the power of 2. That's b to the power of 3. So that's the same thing as here. That's b to the power of 1 plus 2. That's 1 plus 2. That's b to the power of 3. Take note, when we divide, it's a bit different. So a over b divided by 2b. So that is, if we had to change it to multiplication, this would be at the denominator. That's a over 2b squared. So that's something like this. So if you see a if you see a fractions, then you have to divide it. This is just one way of doing it. So we put this in the denominator instead. Now, if we had to add fraction, so 1/2 or 1 over 2 plus 1 over 5, what's the final answer? So if you forget that when we come to multiplication and addition, so here's an example. 1 plus 1 is 2, and then 2 in the denominator is 2 plus 5 equals 7. Now, 1/2 is 0.5 or 50%, and then 1/5 is 20%. So that's actually 70%. Now 2 over 7 is not 70%. What 70% is 7 over 10. So if you remember your fractions, we had to find the common denominator between 2 and 5. So this is not the way to do it, but this, the second one, is the way to do it. So that's 5 over 10, because that's half of 10, and then 2 over 10, which is 20% of 10, equals 7 over 10. So in addition, they must have the same or a common denominator before you can add them together. So if we had another example, this time we're going to use symbols. So x over y plus z over a. What's the common denominator there? The common denominator is ay. So multiplying a and multiplying y. So how do we get the a here and the y here? So what we can do is multiply by 1. So this is x over y, which is here, times a over a. Now a over a is simply 1. That's what we're doing here. So then we add plus, then z over a. So z over a, and in order to get the common denominator ay, so that's times y over y. Y over y is again 1. So we're not changing anything really. We get ax, which is x times a in the numerator, and then we get y times a in the denominator. Then we get z plus y over a times y, which is here, z times y and a times y. So they both now have a common denominator. So if we had, instead of like writing it this way, we can just write it at the bottom, which is ax plus zy over ay. So this would be your final answer. Another example, which is slightly tricky, which is x over 3z plus y over 2z plus z over 3. So what is the common denominator there? The common denominator is 6z. The reason why it's 6z is there's lacking a z here, and then for the coefficients, which is 3, 2, 3, their common denominator is 6, or the nearest one is 6. Because 3 times 2 is 6, 2 times 2 times 2 is 6, and the same thing as 3 times 2 is 6. So again, we're going to multiply it by 1. That's x over 3z times 2 over 2 plus, the plus is here, y over 2z times 3 over 3, again that's just 1, plus z over 3 times 2z over 2z. So we get now the common denominator because we have x times 2, which is 2x, and we have 3z times 2, which is 3 times 2 times z, so that's 6z. And then here, for the second one, we have y times 3, that's 3y, and then 2z times 3, which is 6z. And lastly, that's z times 2z, which is 2z squared. And then 3 times 2z, which is 6z. The final answer now is 2x plus 3y plus 2z squared all over 6z. Now, it's important to note that for multiplication, or division, if you are doing those dividing or multiplying, if the signs are the same, you will get a positive value, take note. And unlike signs will give a negative value. So as an example, 2a times 5a gives us, which is a positive answer, 10a squared. Now, if you had one of them negative, so that's negative 2a times 5a, gives us an answer which is negative 10a squared. But take note, if the signs are the same, then you will get a positive value. So negative 2a times negative 5a gives you a final answer of 10a squared, and that is positive. So take note of that. Another one is 12a squared divided by 3a gives us 4a, so that's 12 divided by 3. A squared divided by a, so that's 4a, which is positive. 12a squared divided by negative 3a, so that's negative 4a. Again, that's 12 divided by 3, negative 3, that's negative 4. A squared divided by a, that's a. And then what happens if both are negative? So that's negative 12a squared divided by negative 3a. That's equal to a positive answer of 4a. There are some terms in algebra, so we're going to tackle some of them. So if we are given, for example, 5k or 2m, these are simply called quantities. So quantities usually have your coefficients and your symbols, and separately, these are called quantities. So in this example, 5k and 2m, I'm representing k with keyboard and m for mouse. Algebraic expressions are, for example, 5k plus 2m, so there's an operation that's happening there. And these, or this, in this case, this algebraic expression must be treated as a unit. So for example, if you double the amount of keyboards and mice, which is given by this equation, you simply multiply 2 times 5k plus 2m. The way we say it in math is 2 times quantity 5k plus 2m close quantity. When we say quantity and close quantity, that's the meaning for parentheses. So the answer for this is 2 times 5k, which is 10k, then 2 times 2m, or make sure you don't forget that it's positive. So 2 times 2m, that's plus 4m. So this is your answer. Another example, if you multiply the expression 2a plus b plus 3ab by the quantity 3a, so take note, expression is this entire thing, and then quantity is just the coefficient and symbol. So multiply 3a, quantity 2a plus b plus 3ab close quantity. So that's 3a times 2a, that's 6a squared. 3a times plus b, that is positive 3ab. And then 3a times plus 3ab, that's plus 3a squared b. If you were to divide an expression over a quantity, so for example, 12x squared plus 9x squared y plus 6y squared over 3xy, since they have a common denominator, in this case that's 3xy, so we write it down separately so that it's clearer, or just to show you what it looks like. So it's 12x squared over 3xy plus 9x squared y over 3xy plus 6y squared over 3xy. And if you remember, when we divide, assuming that they have the same symbols, then we can subtract the numerator and the denominator. So in this case, 2 minus 1, that's just 1 on the numerator, that's x, so 12x over 3y. And then for 9x squared y, over 3xy. So y and y can be subtracted. So that's y minus y, so that's 0. And y to the 0 is just 1. And x squared over x, that's 2 minus 1. So that's x remaining on top. So that's x over 1, or simply x. That's why the answer is 9x over 3. And then lastly, we have 6y squared over 3xy. So x is the same because there's no x in the numerator. And then y squared minus, or 2 minus 1, that's just y to the power 1, or y. So that's 6y over 3x. We can simplify this further because 12 over 3 can be divided, 9 over 3 can be divided, and 6 over 3 can be divided. So we have 12 over 3, that's 4. Then x over y, which we're just copying what's the answer here. 9 over 3 is just 3x. And then 6y over 3x, so 6 over 3, that's 2y over x. So this will be your final answer. Another example, if you were to multiply, so this is just multiplication still, a plus b over a minus b times 3 over 2. So that's 3a plus 3b, which is here. So 3a plus 3b. And then in the denominator, that's 2a minus 2b. Here are some practice problems which can work at home. Feel free to pause the video so that you can probably screenshot it. And I'll see you in the next video.